All right. I think it's time to start. So I hope you had a good first day with sessions at TC so far. So I guess some are still going to have a session after here, then it's data night out. So I hope you had fun. So let's get you warmed up. Let me ask you, who's excited about slow dashboards? Okay, I didn't expect that. There's a lot of people who like slow dashboards. I guess that's the wrong session for you then, because we're trying to make them faster. But okay, let's see. So we have a lot of people excited about slow dashboards, but still, I guess some are interested in how are we going to make the dashboards faster, and then that's the session for you here. So we're here for the session, The Fast and the Curious, and we want to give you practical tips to make your dashboards faster. I'm really happy to be here and see so many faces here that want to learn how to make them faster. With that, who are the people you have to deal with in the next 60 minutes? This is us. This is Miriam and me is David, obviously. And we both work as product consultants in our Frankfurt Tableau office and really excited to be here.
Yeah, so what you must know about us is that we're always super curious on how things work. We're digging into stuff. And also if problems appear, we always want to find out what the problem is. If we found the issue, hopefully every time we search for it, we solve it. We're keen on solving it. However, we're not doing it like these guys here. So you might know them from the movies The Fast and the Furious. Well, I haven't watched any of these movies, but so no worries if you didn't. However, we solve our problems with creativeness and patience. So I think we can take the curiosity part of today's session.
And I guess, as I said, also you have to be curious because that's how you're going to learn what's wrong with your dashboard, and that's how you learn how to fix slow dashboards. And the two of us, we're not only curious, but we're also fast. Also not in the same sense as our friends here in their super speedy sports cars, but we're fast with our bikes. So Miriam and me, we both love riding bikes, and we always have, as you can see up here. And also like fast bike rides, we like fast dashboards.
Yeah, so when I started at Tableau, I had a customer who had performance issues with his dashboard. And because I was new, together with David, we sat together and tried out what the issue is with the dashboard. The result is that we didn't find anything, which was very frustrating. But as I said, we solve our problems with patience. We sat in front of this and, well, we found the issue, which was pretty straightforward. It was a simple blend that was not even needed for the dashboard that caused this dashboard to slow down. So from that day, we made dashboard performance our mission. This is why we stand in front of you today. So let's have a look at what you will take away after these 60 minutes. So by the end of this breakout session, we hope you will know what factors and features drive performance in both directions. So what makes them fast, what makes them slow. More than a general idea of what the issue with the dashboard could be, we want to tell you how you can narrow down the issue with your dashboard and find out what specifically makes your dashboard slow. And we will provide you with a toolbox that you could use to create performing dashboard from the start or repair the dashboards that are currently slow. So as important as the expectations that you should have from this session, we also have some. So first of all, get excited. Fixing dashboard performance might not seem as a very fun topic, but especially if you see how features can really drive performance, you will be excited about it. Also, close Candy Crush, Instagram, and your email program, and listen up. We're very excited to hear your questions. Please wait for the Q&A slide to pop up later on, then you can throw us with your questions. So let me open a dashboard for you. Well, it is made up. Yes, it is thankfully made up. This dashboard is basically never loading because it's a video. But what we wanted to show you with this is that probably a lot of you have been sitting in front of such a screen, waiting for the spinning circle to stop spinning but it never happens. So yeah, if you felt like this, you're not alone.
Yeah, so if you browse the community, you will find a lot of things. So let me see some hands. Who's been there, has been waiting in front of the circle for longer than we actually wanted to? So yeah, I was expecting that. And also the community, as I said, has some issues. Talking about Tableau taking a long time to open or load worksheets, slow performance of Wiz, dashboard performance too slow, Tableau workbook is slow, dashboard taking a long time to load on server compared to desktop. And the worst of it, nobody's liking it. And if our users don't like our dashboards, they won't use our dashboards. So we don't get the user acceptance we're looking for with the Tableau dashboards. And that's actually the point of the whole session. We want you to save the trouble by giving you a set of tools that you can take away to make your dashboards fast in the first place and not going back and try to fix them. Which leads us to our first key takeaway of today's session: performance is not an afterthought. You should not try and design a dashboard and then go back and try everything to make it fast, but you should always design with performance in mind. Think about every single point, everything you put on a dashboard can make it slower. Also, if you're going to see these blue slides, these are our key takeaways. So it's the super important stuff. We want to emphasize this, and we have 10 of them. They're going to have this throughout the session, and I want you, every one of you, to think about your key takeaway, the most important for you, you can take back in your daily work and try to fix your dashboards or build faster dashboards, as I said in the first place. So now that we know what to expect in general terms and have learned about our first key takeaway, let's have a look at the high-level agenda for today. So first, we tackle the holy grail of all questions: why is my dashboard slow? And we're going to find out what can be the specific troublemakers. Then we'll jump into the main content for today, which is first about data-related topics, so how can data play into performance, and then also what can we do in terms of designing a dashboard that can make our performance go down. Then we'll end in a live example so you can experience those tricks firsthand. And we have, as we said, some time for Q&A, and also want to give you some notes at the very end on how you can continue your journey to become a performance Jedi.
So this framework serves as the basis for today's session. There are 3 layers that might affect the performance of your dashboard: design, data, and platform. So starting from the bottom, there's a lot that can go back to the platform. This can be related to the number of users on your Tableau server, but it could also go back to the underlying hardware. So you should talk to your Tableau server admin in case you have the sense that dashboard performance might be bad because of the platform. This could be, for example, if any dashboard that you're having on server is slow, no matter what. However, platform is not related to dashboarding. This is why it will not be part of today's session. Rather than platform, what we often see with our customers is that data and design-related factors impact performance. This refers to bringing data into Tableau and then visualizing it. The higher we go in this triangle, the more frequent we see those issues appear, and probably the more easier it is to bring issues into the dashboard. But the good news is that the more frequent those things appear, the less complex it is to solve them. So that's good news for all of us today.
Another thing I want to emphasize when we look at the framework like this is we don't have a silver bullet. So I don't want to disappoint you, but I want to tell you from the beginning, there's no simple one thing, click thing we can do that will solve all our performance issues in every worksheet, every dashboard, every workbook, wherever you're looking for. It's just, there's really helpful tips we're going to give you today, but they're all dependent on what is your data structure, what is your specific workbook. So they're really helpful, but keep in mind they're really depending on what kind of data and workbooks you're actually having.
So let's do some housekeeping and clear up certain concepts that are important when talking about performance. First of all, a query. So a query can be translated, some of you might know, as a request to the database or not the database, but also an extract, no matter what data source you're using, to bring the data out of it into Tableau. You need it to visualize it and to fill your viz. The second process is rendering and computing layout. So when you pull the data into Tableau through a query, Tableau needs to compute how the visualization should look like and then also create it or draw it. So that process from bringing data into Tableau and then visualizing it takes time. And that time is the minimum time for your dashboard to load. Of course, there are other processes that are important and that can extend this loading time of your dashboard, but these are the most important in terms of performance. And this is why they will pop up once in a while during this session. So let's come to the question of all questions. Why is my dashboard slow? To answer these questions, we will pop the hood. Looking under the hood with Tableau means do performance recordings. They're your best friend when you're having bad performance in your dashboard, and they will help you find out what the issue is. So you should do performance recordings in both Tableau Desktop and Tableau Server to compare them. And in Tableau Desktop, you start them through the Help menu. After you started it, you interact with your dashboard just like a normal user would do, just like you would do when you access it. Then you stop the performance recording in the same way that you started it, and out of nowhere, a whole new Tableau workbook will pop up to show you what is going on behind the scenes.
Okay, before we actually look at the dashboard like this, which is a performance recording, again, I'm going to annoy you throughout the session. Who has used performance recordings before? Okay, still a couple. But still, let's have a look at how performance recordings can look like. And I like that expression behind the scenes because we can actually see exactly what's going on from the time we open the dashboard until we get the visualization or we interact with it. So here we have a typical performance recording. And it basically is made up of three main areas. So let's have a look at the first one. So on the top, we see all the events that have happened in the order of operation. And as Miriam has emphasized before, some events have to be stacked, so they cannot happen in parallel. So we can see we have an executing the query, and then we have visualized or computed the layout. While other events can happen in parallel, like these, so the queries, they can be fired at the same time. So these are some things you should keep in mind. So let's have a look at the middle part of this performance recording. In my mind, it's the most important. It shows us all the events that have happened, sorted by the time they took to complete. So it gives you a really, really great starting point on what kind of things took long, what kind of things you might want to get rid of or might want to get fixed. So let's take the top two here again. We can see we had a query that took more than 12 seconds to be executed. And then we had, on the second one, we have a blue bar. It says computing layout. Again, this took almost 9 seconds to be computed. So it's a rather long time to wait for a dashboard to show up, I would say. And this usually gives us hints on, I would say, complex, large crosstabs, for instance. So they pull a lot of data, and they have to compute a lot of numbers that are actually displayed on the crosstabs. And lastly, on the very bottom, once you click on one of those green bars here, you can actually see the exact query, the syntax of the query, that's been fired to the data source or database.
So what could be really practical is just copying this query, testing on your database for debugging purposes. So performance recordings are pretty cool. They can help you narrow down the issue, especially if you have no idea where to start. So this is worth a key learning. Use performance recordings. We can only recommend it even if you're interested in why your dashboard is even fast. So as awesome as Tableau is, it cannot yet break the laws of physics. This means that there are certain rules that you have to keep in mind when using live connections with Tableau, because they might help you save a lot of time. So when something is slow on your database, it will always be slow on Tableau Desktop. This goes back to the fact that any action that you do sends a query to the database. And if the execution of this query is slow, it will never be faster in Tableau Desktop. Continuing this scenario, if something is slow on Tableau Desktop, it will also be slow on Tableau Server. Tableau Server is not a machine that helps you make your dashboards faster or more performant. It's just there to scale this one dashboard that you're building out to all the users on your Tableau server. Furthermore, on Tableau Desktop, there's just you. You're the only user. But on Tableau Server, as we're scaling out, there can be hundreds or thousands of users. So keep in mind, if something is fast on Tableau Desktop, it does not necessarily mean that it's also fast on Tableau Server, because speed is relative. So after stalking you with the basic concepts about performance, we're jumping right into our first layer, the data layer. So let's have a look at what can go wrong and what tips we can give you when it comes to bringing data into Tableau. So first of all, when you're bringing data into Tableau, don't replicate your whole database tables. That's what we sometimes see with customers. They want to make visualizations, they're pulling all the data into Tableau. It could be wise if you're using data very frequently or parts of the database table very frequently, and also depending on your use case, to break up the database tables. For example, if you're having a database table like this, which could be huge, but for this specific use case, the specific dashboard, you only need a fraction of the data. Split up the data and break it up into views that you are connecting to with Tableau. So this means there are multiple but smaller data sets that you're connecting to, but this is more efficient than replicating your whole database. You could do this on the database backend by making additional database tables, or you can use data source filters in Tableau. Another thing that might seem obvious to some of you, but it's still worth mentioning. So imagine you have a car, like one of these, but you're not, in this case, putting gas in your tank, but you try it with something else, something on your own. For example, with corn or Coke. So I haven't tried it, it might work. But if your car will stop working, I bet it's pretty hard to get help from your car manufacturer or support, or even that he repairs it. So you can somehow bring this up into Tableau. So please use our native connectors rather than ODBCs or JDBCs if native connections are there. They're optimized, tested, and supported.
Just another thing I want to mention here that just came up yesterday in one of the Tableau Doctor sessions. Even if you use the native connectors, make sure that you also use the latest drivers for those databases, because also this can affect the performance.
So the data that you pull into Tableau is the basis for performance. Keep your data and your database clean. For example, breaking up the data into smaller subsets, and make sure you use native connections.
So again, next topic. Let me see some hands. Who knows how to write SQL here? Okay. Who's used custom SQL in Tableau before? Also quite a few. Okay, so Tableau offers this neat possibility to connect to a specific database query rather than to the whole database table or the data set. This is what we call custom SQL in Tableau. Purposes of that could be usually to restructure your data, to pivot, union, or join your data, or in the end to reduce the size of data you bring into Tableau. And I know many of you try to use custom SQL to get around your data modeling, to solve your data modeling issues. And I would challenge you and say, please try to save those data modeling issues by the native drag and drop interface in Tableau. So you might ask why. And it's a totally justified question. Let me explain to you why Tableau can be much more efficient with the native drag and drop interface. Tableau can be seen as a very optimized query generating machine. And Tableau generates those queries dynamically on the things in the view we need to create the view. So if you use custom SQL instead, so you're running a live connection custom SQL, Tableau runs the whole code, picks the data from the custom SQL we need. So we cannot deconstruct the code. So in the end, this can be then translated to performance issues we see quite often. So then you might also ask the question, why and when should you use custom SQL at all? So I don't want to ban it by default, but custom SQL comes in handy to include specific database functions, for instance. But then I would use it together with a Tableau data extract. So you create hyperfiles, you create extracts, you pull the data from your database. The custom SQL only runs once when you create those extracts or when you refresh them, and then it's materialized and will not slow down Tableau. So there's a quick key takeaway. Again, after one slide, avoid custom SQL. So unless it's strictly necessary, try to use the native drag and drop interface to create your data model. And if it's really necessary, you might want to think to push it back to the database or create it within Tableau data extract. So the next part is about bringing data together. So namely, we are looking at blends and joins. Blending and joining are both techniques you probably heard of. We can leverage them to bring data from multiple tables, from multiple data sources, even across databases together in Tableau. And they both have some pros and cons I want to dig into. So let's start by looking at joins. So this is a really simplified explanation, but usually what we do with the join is we have two tables, we combine those tables on row level, then we can imagine a dashboard, we interact with the dashboard. Based on this data, what's happening, we send a query to visualize the data on a dashboard. So it's really simplified, but usually this is how a join works. So let's see how blends work. Again, we start with two tables. What we can see here, often when we use blends, we have tables, data sources on different level of detail. Now, when we use a blend and we interact with a dashboard that, let's say, has a view based on both of these database tables, we send two queries, each to each table. We get aggregated results, and only in the last step, in the visualization layer, those two tables get blended together on the dashboard. So let's have a look at some real-life example and how this translates to performance recording. So on the left, we have a data model. We have an orders table from Superstore. We have a left join to returns. On the right, we don't have a data model, but we have two separate data sources. The blue check mark indicates orders is our primary data source, and the orange one indicates returns is our secondary data source. So now imagine we have a dashboard, we interact with this, it's based on this data. This is how the performance recording could look like. So if we want to focus on some specifics here, we have one query for the join model. You can see it's a bit more complex, a bit longer. We have a select statement, we have a left join in there. But it's one query. It took about 0.08 seconds. When we use a blend instead, we have two queries that's being sent. They're a bit shorter, they're a bit slimmer. That's why they took only 0.06 seconds. But then we needed some time to blend this data together. So this is how the difference actually translates to a performance recording. So both can come in handy, but it's something you should keep in mind when you want to use which. And leading to the question, when should you use which? Joins are usually better on the same data source. And honestly, most of the cases, joins are the way to go. However, joins, they allow you to build a complex data model, let's say it like that. But if you join tables or data sources that are not meant to be joined together, you might end up with duplicates and blow up your data. In these cases, you might want to look for a blend, for instance. And blends are really good when it comes to bringing data together across data sources or with very different levels of granularity, as I said before. And lastly, if you want to extend data sources that have been already published to Tableau Server, you also want to use a blend.
So to better leverage the data or the optimized database that you have now, also create efficient joins and blends and think about when to use what with the tips that David just gave you. So a very popular topic that we see with our customers is, should I go live or should I go extract? So it might come to arguments like this. very often, and you might also have gone through this decision process. Let's just quickly discuss what both are. So live connections are you're querying your database, which could be, well, less efficient than an extract. So with an extract, you're saving the data that you're connecting to in memory. So the query does not go back to your database, which in most cases is more efficient. So extracts are fast in general, but there are still certain issues that you can run into if you're not aware of the following tips. So again, I want to stretch this point. An extract is not a replacement for your database. As well as the point I said before, don't bring all the data into Tableau. Also, don't bring all the data into your Tableau extract because it can become less efficient. Furthermore, the speed of the data engine, the hyperdata engine, is relative. So it is probably faster than any database that is not designed for analytical purposes or flat files. But at the same time, it might not be as fast as a cluster of fast machines that is designed for analytical purposes. Also, there are some factors that can affect the performance of extracts. Very straightforward, the number of rows, just like a database table. So the more data you have, the slower the performance should or will be. Also, the number of columns can affect it. However, that's not in a way that when you interact with the dashboard and the query might be slower, but the number of columns is relevant when you're creating the extract because it might take longer, and also when refreshing it. The cardinality is the number of unique elements and dimensions. So the higher the cardinality, the more unique elements you have, the slower the extract will be. Dimensions versus measures. Measures are numbers. They're easier to process, to store in the extract, and also to refresh. So the more measures you have in your data compared to dimensions, the faster your extract might be.
So much for general concepts regarding extracts. Let me give you some really simple but powerful things you can do to tweak to make your extracts go faster. So the first one is pretty obvious. You can make your extracts smaller and therefore faster. And you can do that by filtering them down. So filtering them down means it contains only a subset of data from the original data source you're pulling the data from. So let's take this example here. I filtered down my extract to contain only data that belongs to the category of office supplies. Often it also makes sense, in this case, to filter down to a specific date range, such as the last 3 months, 12 months, 5 years, 10 years, whatever kind of use case you're looking at. Another way to make your extracts smaller is to make them less granular and therefore faster. So as Miriam said before, we don't want to replicate our database in an extract, so it doesn't have to be on the same level of granularity as our data warehouse. So let's say our database collects transactional data every single minute. But in your analysis, you actually go never deeper than the daily level. So why not pre-aggregate the data on the daily level before? And when you use an extract for a specific workbook or use case, you can go and hide the unused fields entirely or roll up the data to the dimensions you have visible in the view. And also you can use this technique more than once. So you're not bound to one data source and one extract. So you might end up with multiple data sources from the same database, just on different levels of granularity. So the last thing we introduced with Tableau 18.3 is a feature called multiple tables. So meaning that each table you bring into a data connection in Tableau will be stored separately. So why does it matter? Who of you has heard about blowing up extracts before? One here. Or the entitlement issue, entitlement table issue, something like that. Okay, what does it mean? It means that many-to-many joins before blow up your extract so you get millions and billions of rows of data. So now we store the tables before the join actually happens, which makes them, in those cases, much more efficient and smaller. So, key learning number 6, use the extracts, but use them wisely. They usually give you better performance with the emphasis on usually, and they do not replace your data warehouse. Also, another thing I want to mention here is they're not exclusive. So you can use in one dashboard, in one workbook, you can use live data sources, you can use extracts, depending on what visualization you build on depending on how fresh your data, for instance, needs to be.
So after mediating the fight between extract and live, let's have a look at the next layer for today's session, the design section. So the presentation layer or the design layer is related to how your worksheets or your dashboards look like. So let's jump into one. This is a dashboard of Andy Kriebel. We'll use it as an example. It is a dashboard that is, for first instance, great looking. It is relatively easy to understand and to interpret. It's elegant and visually attractive. So why would we have issues with this dashboard concerning performance? Before we're digging into what this dashboard consists of, we're first having a look at how people get to see those dashboards on Tableau Server. So imagine there is a company of 100 people, which is represented by these 4 people here. It's Monday morning, 8 o'clock. People start doing their business, looking at the dashboard to update what happened during the weekend. Do we really need to load the dashboard 100 times in about 10 minutes in the morning? Yes? No? Who says yes? Okay, no we don't, because we have cache. So if the early bird of the company is accessing the dashboard, it will be loaded once. After it is loaded, it will be stored in the cache, so that everybody who's accessing the dashboard afterwards will get to the preloaded view and doesn't have to wait until this dashboard is fully loaded. So that's perfect, and it can maximize increase our performance. So use cache or maximize the effectiveness of cache to improve your dashboard performance. How to do that? So one easy way of improving the effectiveness of cache is using fixed dashboard and story sizes. The automatic size option is very practical, I totally agree. But that basically means that from every device a user is accessing the dashboard will be loaded initially again. So if we have a lot of different devices, the dashboard really needs to load for every device, and we cannot make use of the cache. So use fixed size to make use of the cache, load the dashboard once, no matter what device is used. Also to be aware of is that global caching cannot be used when you're using user filters. User. Okay. So imagine user filters are used. Everybody who's accessing the dashboard accesses his own view, his own filtered view. That means that there's still cache. However, the cache is individual. So every preloaded dashboard is stored in a cache, but you cannot make use of the global cache because every user is seeing his personal view. So plan your dashboards in a way that caching can be used, which will maximize your performance dashboard performance. So use fixed dashboard sizes and avoid user filters if they are not relevant. So coming back to this dashboard, we will have a look at what this dashboard consists of. So on the left side in Tableau Desktop, you see the item hierarchy, which basically shows you what elements are on this dashboard. And there are a lot. Why is this relevant? Because the more elements you have on the dashboard, the more rendering needs to be done. So just put those elements on your dashboard that are really, really necessary, and not just because you can. However, not all dashboard elements are the same. They're non-data-driven dashboard elements, which means it's not connected to the underlying data and thus not driven by it. It could be a text box or a title up there, which is statically typed into a text box. The other kind of dashboard elements are those that are driven by the underlying data. For example, worksheets or filters. It is relevant to know how many dashboards elements are on your dashboard that are data-driven, because with every of these data-driven dashboard elements, you send one query when the dashboard is loaded. So there are several data-driven elements, but the most important ones are worksheets and filters. So we will dig in deeper into those two. Let's first of all have a look at worksheets. Depending on how you design your worksheet, there are other elements on it. However, the most important element on a worksheet is the marks, because they make the biggest difference when it comes to performance.
So yeah, why do marks make the largest or biggest difference in terms of performance? Pretty simple, because marks make a visualization. Without marks, there is no viz. Marks are the dots on a scatter plot, marks are the text on a crosstab, or marks are the bars we have in a bar chart. And as a rule of thumb, try to keep in mind how many marks you're using and try to use as few marks as possible to answer the question that you're building the visualization for. So again, I have an example here with a bar chart. Let's take this. We have the question, what's the average order size for each country we have in our superstore? On the left, we have a bar chart that pretty simple shows a bar for each country with the average order size. On the right here, we have a slightly more sophisticated visualization. It shows dots for each order we have, and we're using a reference line to compute the average for those. So it allows for outlier detection, and it's a bit more sophisticated. If we just want to answer the initial question, I would say this one is the way to go, because it's pretty simple. But if we want to look further, we want to have more like see who are those orders, who are those customers, and things like that, we might need these. The major difference we're looking here at is the number of marks. On the left, Tableau needs to render bar charts, pretty simple, 23 of them. On the right, we need to render more than 3,000 dots on this scatter plot. And it's not only about the number of marks you have in your view, it's also about what kind of marks, what type of marks do you have. So polygon marks, for instance, need quite some time to be rendered. This is then true also for manufactured chart styles like chord charts, Sankey charts, any kind of curved lines. But also maps need some time to be rendered because we have polygons on maps, we have background images, or we have background maps. So in the end, I personally like fancy chart styles. You can have a look at my Tableau public profile, I use them frequently, but the question is, do we really need fancy in order to answer the question? Probably not. I mean, look at this car. You might argue that it looks fancy, it looks cool, but I don't think it will really go fast on the Autobahn. So let me sum this up with some worst practice. So looking at this, we have a lot of sheets, we have complex sheets, we have complex mark types, polygons, maps, we have a lot of marks on these scatter plots, we have maps here. We have, as I said, many sheets on one dashboard.
And also think about the dashboards down there. If you have a look at them, there are a lot of them in there, and if every dashboard looks like this, it's going to take a long time to load.
Yeah. So to put it simple, keep it simple. Key learning number 8. So try to keep your dashboard simple, try to keep your worksheet simple, and try to keep your mark type simple. Because we can see that poor design equals in poor performance. So in my mind, this might be the most common issue we see for performance trouble. I'm talking about quick filters. So this doesn't mean we want to ban all quick filters by default. I mean, there's a reason why Tableau offers the possibility to use quick filters. But you should use them with caution because they can be costly in terms of performance. And talking in general, too many filters slow you down. This is true in terms of how a user would interact with a dashboard like this, but it's also true in technical performance. So let's have a look why filters are bad for performance? So before we can answer the question, I want to divide them in two major categories. We have so-called enumerated and so-called non-enumerated filters. So it sounds complex, but it's pretty simple. Enumerated quick filters require Tableau to query the database or data source before we can render the filter. With this example, we want to allow our users to be able to filter to a specific customer name. In order to have this filter on a dashboard, Tableau runs back to the database, fetches all the names of the customers that we want to display in the filter in order to actually display the filter on the dashboard. And then when you talk about user experience, the user have to deselect probably all, then select all the names he's looking for, which will again each send a new query. So let's have a look at non-enumerated filters. These are filters that don't require Tableau to know about potential field values in order to be displayed. For instance, we can have a wildcard match. So the user types in the name he's looking for and just selects the name. It's straightforward, it's simple, it's easier for the user, and it's also much better for the performance. Because if you think about the initial load, Tableau runs queries for all those filters, and we don't need this to be the case for non-enumerated filters.
So in the case you still want to use quick filters, let me give you some tips. First of all, you all might know this apply to all worksheets option in the filters menu. That means that if you select a value, all worksheets will adjust to the selected value. This is what we call global filters. However, every worksheet will send a query back to the database when you select a filter. So think about it if you really need every worksheet to update when you select a quick filter. Also use the apply button, especially when you're using these multi-select filters, because if with apply buttons, you can select every value that you want to include and then click apply, which means one query to the database. Not using the apply button means one query per selected value, which really can decrease performance severely. Also avoid the only relevant values. I know it's very practical, but still, if you're updating or if you're selecting one value in one filter, all other filters will adjust. This is one query to the database because the filters need to know what values to display that are relevant. So rather use the all values in hierarchy option, which is new since 2019.1. Also, use the default include values, and please refrain from the exclude values because it makes your query statement more complex, and it's just, nothing really different. So, quick filters have their place on dashboards, but just keep in mind what happens when you're using them and how you're using them, because this can be a decision that can be very expensive in terms of performance. Also, traditional filters are not the only option. So David, tell us what there is more.
So then let's have a look at what is the other option. So bear with me for a minute or two. So we've seen that design and performance are intrinsically related. So let's first have a look at our, let's say, worst practice dashboard example from before. How would a user interact with a dashboard like this? So first, we throw a lot of data at our users. We can see this by the scroll bar here. Then if a user is interested in specifics, he has to go back here to the right side, select, deselect all filters. The filters are not even consistent, so we're using different kinds of filters. It doesn't really seem user-friendly to me, because we have no visual guidance, we have no context, and in the end, Vin Diesel does not approve. So let me show you another way. Let me show you the other option. That's something we call guided analytics. So how does a dashboard using guided analytics work? So first, this dashboard gives the user an aggregated view. So it's a slim query. It shows all the data just aggregated on every state level. When a user interacts with the dashboard like this, we click on the state of California because it's darker, we're interested in this. We click on the longest bar chart, and only then we drill down to the deepest level of granularity of the things we're actually interested in. So this is really good for the user experience because the users can easily ask and answer the question, but it's also really good for the performance. So if you look at the dashboard when it was first loaded, it was a really slim query aggregated to every state. And only after we click on California, we query the database for the next granular level, which is cities. So the query gets filtered down. After we click on Los Angeles, we filter down again, and only then we query the timeline. So this makes the queries a lot faster, and also Vin Diesel likes it. So, as I said, guided analytics is key. It's better for the user experience than quick filters, and as a nice side effect, it really helps the performance. So with that, let's jump over to Tableau and have the live demo as promised. Let's log in here. Demo effect.
We haven't thought about that. This will go to sleep.
So let me tell you before we jump into the dashboards, you will see that those dashboards will not take forever to load. They will rather pop up instantly. This is not because the dashboards are really fast. This is because we didn't want to stretch your nerves, and we pre-cached all the dashboards, we pre-cached the queries before, so if we jump in, they will show up instantly. But as you can see here before, in the end, we show you how the performance recordings differ from each dashboard we're going to show you. So before looking at the first dashboard, let's give you some context about the data. So if we zoom in here, we're looking at flights data. So we have information such as which airline was this, where's the flight coming from, where's the flight going to, which was the date of the flight, how long did the flight take, was it delayed, and these kind of things. So let's have a look at how much data we're actually looking at. So we'll track in number of records here, and we can see we're talking about roughly 144 million rows of data. So I wouldn't call this big data, but I would say it's a substantial amount of data that can already be slowing us down if we are building bad dashboards. So let's jump into the first dashboard, which we call slowest. So your mouse is gone, the cursor is gone. Demo effect. Okay, let's do it
without a mouse.
Without a cursor. Okay, so this is the slowest dashboard. So first thing we see, we have hashtag give me all data. We have a large scatter plot with actually every flight we have on our data set here. So we throw a lot of data at the people, and it's really like, what are our users supposed to see on this scatter plot? Not much. So if we're really interested in something like filtering down here, so let me try this again here. So if I'm gonna filter down on a specific year, which is not working, because the cursor is gone. So
here we go.
Back we are. So let's see. If I'm interested in a specific year, I have to go back here and say, okay, let's say I'm interested in 2008. So I click 2008. We'll load the data. And again, I would say, okay, I'm interested in a specific state. For instance, I'm interested in Arizona. So you see what's happening. I have to go back on the right, I have to select a year, a query gets sent. If I select multiple years, another query gets sent. If I select a state, a query gets sent, and so on and so forth. So it's not really good for the user experience, and it's a lot of data we need to query initially when we fire up the dashboard for the first time. So let's have a look at something we call slow dashboards. So you might have guessed it's still not something we want to have our users build, but still it's something that works better. So the major difference for the slow dashboard is it still has all the data on the same scatter plot, basically, but we can see we're using different kinds of filters. And these are the non-enumerated filters for this, in this case. And this is just to show you guys how much difference the filters can make when we can see later on the performance recording. So if I want to filter to a specific name here, again, instead of selecting, I'm going to type Arizona, and then I select this. It's still not the best in terms of user experience, though. So I would say,
let's have a look.
Show us the fast dashboard.
Yes, at the dashboard that we call fast. So if I'm selecting it, even if it was not preloaded, this dashboard will appear very fast because what we basically see is nothing. Well, just a timeline. And that's all about it, because this dashboard follows this approach of guided analytics that David just showed you. So what we do here is we only visualize for initial load this timeline. Then I can select a year that I'm interested in, and rather than filtering down to any state that could have potentially interesting insights, I can directly see which states are interesting to me. So I could select California now. And now I drill down to the cities where I can also see where outliers are and where the interesting part of the data is. And only then I get the end result that I have with the others before, but much more faster, much more insightful. And furthermore, we're using an extract with this fast dashboard. For slow and slowest, we used a live connection to a SQL database. And in this case, we used an extract. So we improved performance with design, but also with the data connection. But there's more to gain. Let's jump into the fastest. It's looking similar. We're not using a timeline up here, but we're using this relative date filter. But we're having the same analytical guidance as the fast dashboard. But what is the difference? Just let me show you what the underlying data is. So we're not using the SQL database's live connection or the extract, but we're using an aggregated extract. So if I pull in the number of records, I can see that we severely decreased the number of records from 144 million number of records to only 48,000. So how did we do that? We used key learning number 6. Use extracts, but use extracts wisely. So I selected the live query, wanted to extract the data, and rather than extracting it, I first aggregated it and rolled it up to year. Because there's no more detailed view that I have on my dashboard that would go further down than year. So I will roll it up to year. This will decrease the number of records and make my extract faster, and thus my dashboard faster. So let's have a look at the comparison of all these dashboards.
Yeah. As promised before, let's have a look at the first one. So you can see we have stacked bars, and the whole bar basically shows how long did the dashboard take to be loaded. So we did the recordings a couple of times and took the averages of those. We can see the first dashboard for initial load took almost 23 seconds. And I would argue that's something no one wants to wait for. We can see it's based on a SQL database, and the same is true for our slow dashboard. But we can see we decreased the loading time by 50%. So now we need 9.7 seconds instead of 20 to execute a query. And this is only because we don't load all those filters in the first place. Then we had our fast dashboard, which was then based on an extract, which made it a bit faster again. So we can see the query took about 5 seconds. And then we had our aggregated extracts, which made the query again faster. So we have only 3.4 seconds. And we can see it took a bit longer to compute, which is obvious because for initial load, we showed a map which has polygons instead of just timeline, for instance. And so if we look at this overall, we can see we improved our performance by 75% from the slowest to the fastest dashboard. So let's go back to the presentation, and I think we have, let me see, 2 or 3 minutes before we wrap up our session, so we can also stick around for a couple of minutes after if you guys have some specific questions, but any questions right now?